Good afternoon and welcome to Stratosphere Session 9A. My name is Gerald Hill and I will be one half of the presenters today. You'll also hear from Tariq Ali. We're going to share with you two projects that we're pretty excited about. They do connect together. And the first one is our Azure land and zone base cloud architecture, and Tariq will be presenting the Guardrails compliance tool. This is an initiative from Cloud Product Management and Service Directorate under the Cloud Research and Development Division. Our director is Jacqueline Marcos. So the concept here with the land and zone based cloud architecture was really to create a repeatable pattern through automation to deploy virtual data centers in the cloud. So that was the concept. So what we've done is before we started and we started developing our scope statement, we listed a bunch of objectives that we wanted to adhere to throughout the process. So I think it'll kind of help set the stage as to what has been included in this virtual data center, and then we'll go through next 6 sessions that we have developed to step a partner through pretty much ground zero to having a fully functional virtual data center in the cloud. So let's start off with some key objectives from our project. One is to be CSP agnostic. So our solution had to be able to be applied through multiple CSPs, which we have. This session today will specifically focus in on Azure, but we've also developed a solution for AWS, and we'll be looking at other CSPs as we move forward. The design had a single tenant, single department in mind. So it was to create a virtual data center for a department. So you could visualize a legacy data center. So, however, the idea, once again, was to make a repeatable pattern so that partners can excel, so we can help excel partners with their journey into cloud. We needed this to be at a PBMM compliance level. So as far as ITSG 2238, zone and network design and IP management, that is all built in. SSC, virtual PBMM compliancy. So that is true. Right now, our current design supports Cloud Usage Profile 3. And if you're not used to hearing that phrase, Cloud Usage Profiles, basically it's a connectivity method. So for Profile 3, it means that there's no ground to cloud or cloud to ground connectivity required for that service. When SCED is available to us, which will be soon, we will then build in the components required for profiles 5 and 6, which includes ground to cloud and cloud to ground. So for those of you that don't know what SCED is, it's another project within SSC, and it's a secure cloud enablement and defense, SCED. So once again, we want to accelerate partners' SNA process. We've done this by producing numerous artifacts that the partner can leverage, as well as we have a good feedback loop that the SNA, the assessor's feedback in Dust, will help improve those artifacts. We also have the security compliance tool that Tariq will show a little bit more about soon. And it's also used for evidence gathering. Naming and tagging is an extremely important functionality for governance for cloud. I will expand on this a little bit more, but we have created a name and tagging standard that can be leveraged by GOC. Alignment between CSPs at the architectural level. We wanted to make this as easy as possible to support. So we wanted to align whenever possible architecturally between the different CSPs. Security, automation, and compliance. I'll leave that for Tariq to expand on a little later on. We wanted to contribute to the GC accelerators, which we have. Use cloud native tools where possible. Automation via cloud agnostic provisioning tool, and automated code pipeline. We have accomplished this by some in-house developed solution and Terraform. Share our infrastructure as code through an accessory repository for departments to leverage. That has been done. We first wanted to utilize this internally. The phrase drink your own Kool-Aid comes to mind, so to speak, which we have, and we wanted to identify pathfinders to deploy the solution for, which we have. And the two pathfinders that we currently have, this solution has been deployed in their cloud and ready to support, and some are actually supporting PBMN workloads today. So the Azure base cloud architecture, we've come up with 6 different sessions that we can take a department from ground zero with no or very little cloud knowledge to having a fully functional PBMN compliant virtual data center. And when I say PBM compliant, I'm referring to the technical controls around the base cloud architecture. So what I'm going to do, and plus also I should mention that we have adopted the Microsoft Cloud Adoption Framework, which you'll see some more information about this later in the slide in session 6 when we dive a little deeper into the enterprise scale architecture. So what I'm going to do is step through these 6 sessions really quickly and give you kind of a layout of what we cover in each. So governance and subscription design. Once again, we never know the level of a department's their knowledge, so we start from the finish. Some of these sessions would take a half an hour, maybe a half a day to go through. There could be some breakout sessions. It really depends. So we first really start from the top. Azure enrollment and the billing system. Explain what that is. We talk about the hierarchy, the management group, subscription and resources, Azure Active Directory, how they link together, define operational models. So we talk about AppOps, which is more your traditional horizontal support where there's multiple service lines that would manage a particular delivery of an application. And then the DevSecOps methodology where all that is built in within one team. And it's usually that application operation team that would manage that. And together, this would help complete the tenant hierarchy design for the BCA, and then preparing for our next session. Naming and tagging. Early on, we were tasked with creating some standards around naming and tagging. This governance is very important. It was something that was asked to be developed by CSE and TBS, and SSE has taken that on. Basically, what our goal was here was to create a governance framework that also supported the maximum flexibility to meet, different departments' business and technical requirements. So you see things are broken down into fields. The first 3 fields of the naming strategy is part of the governance fields. The first field is a department code. That's a 2-letter identification code assigned to each department. Environment, whether it's production, sandbox, UAT, whatever it may be, and the CSP in region. So if it's AWS and Central or Azure East, whatever it may be. The department defined stream is where the flexibility comes in. This enables the department to use existing naming strategies that they have in their legacy environment. They can plug it in here. As you see below, this is how SSE implemented this standard. We use our SACM standards that we developed for end state. So we identify the device type, and then we have a user-defined stream, which is also part of our standards that defines the workload that this resource is running. And then we have a suffix. We line that with the CSPs as much as possible. So this becomes the standard. It's more in depth, and we have detailed design specification that you can reach out to us, and we're more than willing to share and help you through that process. Session 3 is all about the network. So we define the virtual data center. We review the TBS cloud profiles, the external connectivity designs, and assign an RFC 1918 CIDR address block. So what we've developed here is really, this is the start of our automation. We've developed a couple front-end configuration spreadsheets that feed into our pipeline. And for the instance here, we asked for a /16 block from the 1918 CIDR address block, and we type that in, and that automatically self-populates all the zoning that's required. Pretty neat. We also review, the components, the ITSG 22 and 38 architecture, and how that IP strategy rolls out. We also discussed AppOps versus DevOps and the implications to zoning design. Detailed walkthrough of the base cloud architecture network design and IP address management. This also comes, we also have developed all our diagrams. We use infrastructure as code with markdown files that explain everything. It also has a detailed design of all the components that make up the base cloud architecture. And that also comes as well through part of this process. So those are documents that you don't necessarily have to design, they're already made for you. Session 4 is the policy and access control and RBAC. So we review and configure the IaaS related tenant AAD configuration. So this is made up of 2 different documents. The security baseline is TBS and SSC maintained baseline security control document for everything cloud. Then SSC Guardrail implementation is a documentation that we've created to help people's understanding around the guardrails, the 30-day guardrail specifically, and how to apply those to your tenant. We would prep the tenant for infrastructure as code deployment, things like log analytics and so forth that needs to be set up, your subscriptions, assign PBMM Canada Federal Blueprint extensions, create the Terraform service principal and client secrets that will be used in session 4 when we actually deploy the customized virtual data center to your department. And we also would talk about some of the decisions around ground to cloud mapping for RBAC and IAC, or IAM, sorry. Session 5 is Azure. So this is really our whole pipeline. This is our automation that we've developed in our land zone based cloud architecture. And we really focus on the continual improvement cycle throughout this. So you can think of the previous 5 sessions. That would be the plan, and we would design the architecture, the customization to your department needs. Then we would, through a couple architecture reference spreadsheets, it's about 10 fields that we got to fill in to customize it. That would run through a pipeline, PowerShell pipeline that would create the entire Terraform code that's required to deploy a virtual data center. We would do a build, a plan and a build, make sure that it works out well. We would do a sample application deployment. Everything looks well. We would release that into production. We would deploy it. Cloud ops or department ops, whatever that is, would do the operation. We have created some automation around compliance around the PBM guardrails. So that's the monitoring side. Tariq's going to touch a little bit more on that. And then we go back into the plan. Now, part of the test strategy after this is released and deployed is we do go through a walkthrough and some post-installation steps to set up things like install certificates and local AD accounts or WebTop or things like that. All right, so session 6. So this is really where we implement the CAF and more specifically the Microsoft Enterprise Scale LAN and Zone. So this is pretty neat stuff, pretty fun to play with. We worked very closely with the CIO, so the CIO and CTO worked close to implement automation of this Enterprise Scale LAN and Zone architecture. So the current release leverages the follow design. So once again, we leverage the automation through Terraform. Based on the Microsoft Cloud Adoption Framework, Enterprise Scale, we support L0, L1, L2, delegation of code ownership, and RBAC. So I'll just dive a little bit into that. So we use what's called Rover, and Rover is a Docker container, and it's used to create code, update, and destroy Azure resources. So it's like Docker versus code or Git. So we stand up that container base. It runs on a local machine, and it really is. So from that, we would then launch L0. L0 would be the components like manage your state of your deployment. It would store the accounts the Terraform state in cloud accounts for execution. It would use key vaults for shared secrets and certificates, so none of that stuff is local. We're making your deployment very secure. It would also implement the logs to monitor and the extensions required for that. L1, that is the foundational data center components that would be inside this enterprise scale LAN and zone. Things like your application deployed followed by SSE policies, governance, enforce proper tag and naming, PBM controls include the networks, DNS, security center, policies, Sentinel, peer and access control, monitoring, all that stuff, all inside a subscription. And also things like the cloud to ground and public cloud networks. It'll help integrate that. L2 is your application development and deployment. So includes your VMs, your storage, your PaaS components, key vaults for that environment, network rules, required application services. That's your L2. This is all part of that new DevSecOps environment, right? And this is all built inside a single subscription that can be managed within that one group. Yes, so, and then this can all be accessed through what we implemented as the WebTop with ADFS and MFA integration. So it locks it down and makes it a very secure LAN and zone inside the LAN and zone. So through this process, we definitely had some challenges, and I'm just going to highlight a few here, and then I'm going to pass the ball over to Tariq to talk about the Guardrails tool. So the main challenge here was really retooling. Selection of CSP agnostic tool sets that were extensible and adaptable, configuration deployment tools, open, and we really wanted to stay open source. So there was some retooling around that. No longer manually installing an appliance. It's all virtual based and maintained through infrastructure as code. Rapid configuration orchestration system. A lot of development around this through configuration spreadsheets and a transformation PowerShell script to auto-generate that whole infrastructure as code that makes up your virtual data center. So there's maybe some learning curves and some bugs that we had to work through there. Network configuration. You know, in a software-defined world, there's just a little bit of a learning curve for each different CSP. So firewalls, load balancers, the detailed setup of the traffic flows and control mechanisms for that deployed workload. And also working with and developing through CI/CD pipelines to set up and deploy production and test environments. It definitely was a challenge. So we're pretty excited. I hope you feel free to contact us. There's going to be some information at the end. We're definitely willing to share everything that we've learned over the last 9 months of developing the solution. So right now, I'm going to pass it over to Tariq to talk about the Guardrail tool. It's all yours, Tariq.
Thank you, Gerald. Thank you, Gerald. So now I'd like to talk about our second complementary product, which was created alongside the virtual data center-based cloud architecture to help in the overall compliance effort. So we have created here in the R&D team a standalone PowerShell-based automation tool that is specifically designed to extract evidence from the subscriptions that are used to deploy workloads. In this case, the virtual data center, or for that matter, any other workload that is deployed in a cloud tenant. And the specific first target that we went to achieve was to cover the 30-day guardrails as defined by TBS, which are a requirement for compliance for any PBMM workload. It's important to keep in mind that the tool that we have developed does not provide 100% comprehensive coverage of the 30-day guardrails, simply because not all of those elements can be automated. Many of them fall outside automation and outside the API. As you can see from the Venn diagram at the bottom of the slide, our tool covers a subset of the control mechanisms. The Azure portal compliance tools that are built in cloud native do cover some of it, and some of these compliance elements are completely outside of the portal and the tool. They are business flows that need to be done manually outside of the technical piece. However, nevertheless, our tool is very powerful and serves to collect the evidence necessary to validate that somebody has met compliance in their workload, and also to accelerate the SANA and the ATO process, because both of those processes require detailed evidence to be acquired. Now, the examples we have already implemented in our tool are quite comprehensive. We have covered many of the gaps that we found in the Azure portal compliance tools. Now, this implementation of our tool, the current implementation, was a first pass attempt at covering Azure. We have plans in place to keep this a cloud service provider agnostic tool with soon to come AWS coverage as well, and we can expand the coverage to additional cloud service providers. So we gather evidence directly from the Azure subscriptions that have been used to deploy the workload, and we do provide remediation advice as well directly in the tool report. So by that I mean, if you find that one of your controls has failed, alongside the same piece of evidence showing the failed control, you will receive and be able to access information on how to remediate that failed control. We'll show that in an upcoming slide. The findings are fed back to what is called a Master Office 365 Guardrails document. This is a central reference which is jointly maintained by SSC and TBS, which serves as a master reference for all the guardrail controls and details around the validation across the various cloud workloads. And that covers IaaS, PaaS, SaaS, etc. So our subset of that master document is where we receive our information from and where we feed back our findings. We also leverage CIS, which is an industry standard for compliance validation, which does cover both Azure and AWS and other providers. And we do utilize in our script mainly PowerShell and Azure API as a first pass in our implementation. Now, we found during our cloud journey, when we started developing the base cloud architecture, that there were certain limitations in the cloud service provider compliance tools, and some of these were quite severe. So, for example, in the Azure portal, we found that there was a limited subset of controls that were reported upon, and many of those did not align with the 30-day guardrails or the full PBMM control set that TBS has defined as our targets. And some of the guardrail evidence, the control evidence presented by the console tool was also incomplete, lacking in detail. Not only that, we are not able to customize the portal tools today. We have to accept whatever format we receive, and there's no room for flexibility in terms of what we're scanning and what we're checking. In addition, there is a certain delay, a lag between any change request we make to the cloud service provider and any update that they make in their portal to meet our needs. Not only that, the portal tools are integrated into the cloud service provider portal and cannot be integrated with our systems. they are locked in, so we cannot really interact with them directly. And probably the biggest limitation of them all, when you run a cloud service provider compliance tool, you are locked into that specific tenant that you're running in, whereas our tool was designed from the get-go to be a multi-tenant tool which can scan multiple cloud workloads across multiple providers at a high level and provide a unified reporting mechanism across various targets. This is an example of the tool interface as it stands today. You can see here that we divide the information into three major categories. Compliant controls, things that have been found to meet compliance. And the second tab at the top in the middle of the screen is non-compliant controls. These are areas where the tool has found a deficiency, a failure in validation. And finally, manual controls, the third tab. What we mean by manual are those evidence aspects, guardrail controls, which cannot be automated. They are nevertheless part of the required set, and they need to be implemented manually. You can see here the various columns of the evidence that we provide, the requirement ID, which refers to the overall guardrail, and the guardrail control number, as well as the name, title, definition, etc. Some of the automation aspects are covered in the third last column, the audit procedure, and the remediation that I mentioned, where you receive information to correct compliance failures, is in the fourth last column, right after the center. There is also the provision of detailed evidence in a link on the rightmost column. Those are hyperlinks which lead to actual output from the subscription. And a sample is provided at the bottom of the screen. You can see an example of what kind of information we're pulling out of the subscription. So for every compliant and non-compliant control where API interaction is possible, we do provide a detailed evidence file accessible through a hyperlink. This is an example of the automation that we have currently developed and is now in active development. We have envisioned a system where, using Azure automation accounts and runbooks, we're able to invoke our PowerShell scripts to scan multiple subscriptions and multiple tenants. And the result of that is a comprehensive report which can be referenced as a master index, which then leads to individual sub-reports for individual tenants. These reports are stored in an Azure blob, a storage object, and they will then be utilized in one of two ways. A secure report portal, which will be made available to designated individuals with a strong RBAC mechanism to control access. And this will make available reports on a regular basis to interested clients. And the second option is to do business intelligence analysis using Power BI, where we take the HTML reports that were generated, ingest them into Power BI, and we're then able to do trend analysis and do forecasting and other kinds of data analysis. So this system that you're seeing on the screen has already been developed and implemented in a dev environment, and we are now making improvements to it as time goes by. I'd now like to hand it back to Gerald.
Thanks, Tariq, for a great explanation of our compliance tool. Well done. On the displayed on the screen is our contact information. Please feel free to reach out. We only have 25 minutes to present, so there's a lot that we did not cover. We just really scratched the surface, highlighted a few things, but we have a very well thought out and documented solution. What I should have mentioned earlier that I didn't is it can be a managed service, so we can help this for any partner to move through this and get into the cloud. So with now, I guess I'll leave